show you how to use this Unidata ToolsUI to open up a NetCDF file. So if you Google on Unidata ToolsUI, you'll find you go to this link here and you can just download this file, this jar file. And once you've got it downloaded, you can, wherever you downloaded it to, and just go to that directory. And I've got a bunch of them here, but this is the latest one here. Down at the bottom, if I right mouse click, I can say open with, and it'll ask me, okay, yeah, I'm going to open it with Java. So you want to open this thing with Java. If you don't have Java, you can go to java.com and download it. And so this is just, this should work the same way on any machine. It's just a Java application, and no making or anything required. So it comes up with this kind of goofy logo here, and then it comes up with this this kind of funny interface. And notice there's no help here anywhere. So, but you can open up a file on your local file system here, a NetCDF file with this open local data set. So if I click that, I come up and I have this file chooser. I can, let's see, I can navigate to a particular directory by typing it up here and clicking this down arrow here, which is kind of a goofy thing. But anyway, so now I'm looking in here, and here's this file that I output from ARC and in the Albers projection. So I want to bring that up. It's actually already selected here, so I go ahead and open it up. And if I'm in this sort of viewer mode, I can see the variables over here. These are the dimension variables x and y, and these are the actual data variables x and y. But if you take that URL, I always do, I do Control A, Control C, and if you open it up in this NC dump tab, so I'm going to Control V and dump it in there, just so I don't have to go to the open thing again. I get the sort of standard NetCDF dump, and in this case, I can look down here. I can see that I've got a floating point variable of this size here, and this is actually some elevation data, and it's got this grid mapping attribute, which points to the Albers conical equal area variable, which is this variable here. And if I look at this variable here, I can see that it's got a grid mapping name, equal area. It's got a central meridian, but it's got standard parallels, but it does no information about the ellipsoid. Okay, the information about the ellipsoid is actually here in the file, but it's in this custom Esri string encoded in here, and it's not specified down here in the Albers conical equal area. So, for instance, so here we can see that this has a spheroid, which has the major axis and the inverse flattening parameter. Those should be specified down here as attributes per CF conventions. And another way you can verify that this data is not really is going to plot strangely in CF compliant applications is you can click on this feature types tab over here, and then under grids, which is the default. Again, if I drop the same URL, so this T rasters Albers, and I could have clicked here again, I hit return in here, it comes back and tells me that it found this particular variable, and it actually figured out that these were the coordinate variables, and it has this axis type. But a quick way to see if it's displaying properly is to put this funny little alien guy here. And this will bring up a grid viewer window. And in this grid viewer window, you can pick which parameter you want to project or to plot up here. In this case, there's only one. So you can click this little guy again, and now you see this, the data projected, plotted up on a map. And actually, this is a very crude coastline. You can actually use a more detailed coastline here by clicking this little button. And now you can see that the outline of Cape Cod, it's all shifted here. These islands here, they're supposed to be lying on top here of the coastline. Here, on Martha's Vineyard, this is supposed to be lying over here. So if we had the ellipsoidal information in there, this would plot correctly. So that's about it. Thanks.